Right on. So what we're seeing here is a point data for, where individual crimes were located from 2001 to present in Chicago, and it's a little bit of an overwhelming map. It's kind of hard to see particular patterns of where the crimes are occurring. It looks like Chicago is just crime everywhere you go, and that may be kind of true, but and the purpose of this map was to play around with the XY, so data to, or table to XY locations tool, which was successful. So in terms of the assignment, like right on, I think there's some elements here. They've got the scale bar. It's a little bit dark. It's kind of hard to see that, the black against the very dark gray of Lake Michigan. But there's good things going on here. But I did think this was an interesting one to play around with, to talk a little bit more about this sort of density mapping tool, which is what you guys will be doing in the next lab. And so and one tool you have at your disposal is this kernel density tool. And this tool I described a bit, and this was used in the paper that we read last time. But basically, it's creating a surface. Right, is taking point data or line data, some kind of vector data in these points, and then the tool runs on those guys, and it puts out a raster surface, and so there's pixels in here, and each of the pixel value is basically giving a kind of magnitude per unit area. So it's kind of a density, like within this area, how many points are within a surrounding sort of search distance. And so the darker the blue in this case, the more points there are, and then the lighter the blue, the fewer points that there are. And it's useful because it can take individual point data, which can be quite overwhelming, right? And it can sort of convert it into a surface which is maybe a little bit more interpretable. And again, the paper that we read last time talked about this. And they used, points that were recorded from their ABS system, and that's shown here with these sort of weird perspective maps I don't really care about, but But the points that we're seeing are these data points that then they ran that kernel density tool, and they created a surface, and that's what's shown here, where it's clear. There was very few helicopter waypoints, 0 to 16. 0.58, and then the blue is this mid-level 16 to 73, and so on, and then the red is very high. I'm just going to take a moment here to add additional criticism to this paper, and it has to do with these sort of legend values here. Just because the computer can calculate a precision out to the 100th millionth place or whatever it is way out here does not mean that has any meaning to it, or that it should be displayed in a legend. So this should really probably go 0 to 20, and then more than 20 to 75 or whatever, to go out to this 0.9612. This is a pet peeve of mine, but I totally hate it when people do this, because these small decimal place numbers there's no value to it whatsoever. It clutters the legend, it's confusing, and it just signifies that the person is not really understanding what they're doing. So I would encourage you guys very much going forward that if you make maps with legends, that the decimal places that are shown they're only meaningful ones, right? And what we're seeing here is not very many meaningful decimal places, but I digress. Okay, so again, back to this idea of the Chicago police stations. So in the time we have, I'm going to try to go through this process, and I've downloaded data from, just like you guys did, from this sort of crime place, and I'm only going from 2001 to 2011. It's going to be a subset of the data. So I download that data, and I get some kind of a spreadsheet, and I need to bring that spreadsheet into ArcMap, and And luckily, you guys have all kinds of resources about doing this kind of thing, including a lovely video that Maybelline created for us, which is adding XY coordinate data to a map. So if we wanted to, we could watch that video. I've watched it, it's fantastic. It's, and then, so we're gonna do that process real quick. We're gonna add data, we're gonna add XY point data. So it brings up this XY table to point guy. I'm gonna search for the table. And so here it is, crimes 2011, the CSV guy. I'll choose that output. I got to choose the X and Y fields, the longitude and latitude. And so by default, it sort of found those guys. The coordinate system, this is geographic coordinate system WGS84. If we were to look at the metadata of the data itself, it would hopefully tell us that that's what this is. So we're going to run this guy, run this turkey. And hopefully it's going to work, and it's going to bring in some point data, which are, you know, crimes in Chicago. And again, there's a lot of rows here, and we can see that looks like, and this is an interesting situation. I don't know if anybody else experienced this. There's points up here in Chicago, and then, oh my goodness, there's points down here in, I don't know what's going on down here. So maybe there's they had a case down here in West Plains or something, but really the data that we care about are these data up here in Chicago. So we brought these sort of points in, it's crime, right? And so if we open up the attribute table, we can see all these, you know, so deceptive practice. Oh, what a terrible thing to be deceptive. Deceptive practice, narcotics, burglary, sex offense, all these terrible things, right? And so we could isolate these data to only look at, you know, particular crimes we're interested in. We're just going to look at all the crimes here right now. And again, these points, if I zoom way in, you'll see that, oh yeah, so it's points, right? It just looks like a flood, just a complete layer of blue. So using this kernel density tool, so let me type up here. Kernel density, the spatial analyst tool, it'll allow us to convert these points, you know, from this sort of messy point file to a surface, which should be a little bit more manageable for us to see different types of spatial patterns. And so this kernel density guy, so, okay, what's my input? What's my input? Oh, it's the crimes. What's the population fields? We're going to say none, but if you had, if these points were representing, you know, counts of something, you know, counts of bird sightings or something, we may want to weight the points differently. The output raster will have this name, kernel ID CRIM1, the output cell size. So the computer automatically put this value in, the 0.0166, blah, blah, blah. What is the search radius? There's nothing here. And it's going to put out densities. The method could be used as planar and geodesic. So planar is the planar distance between features will be used. The default geodesic is and this is, are you thinking about, you know, the Earth as just sort of a flat representation, or are you actually thinking about it as a globe, a three-dimensional surface? If it's a small area we're mapping, planar is fine. If it's like all of Africa, then you want to start thinking about, you know, taking into account the Earth's curvature. And we can put some different barrier features in here as well. I am a little nervous about this tool because the output cell size is this value that, like, this doesn't make any, you know, this is hard for my brain to kind of wrap around. And so before I run this tool, I'm going to do a right click over here and go to properties. And I'm going to go to source, and I'm going to go down to spatial reference. And we see that it's in geographic coordinate systems, and the angular units are in degrees, or in decimal degrees. Okay, so that's fine. But if I'm thinking about making a point density map, and it's related to, you know how many points are within a given area, working in degrees like makes my brain hurt. And so I would prefer to work in something that had different units like meters, because it's a lot easier for me to think about distances in meters than distances in decimal degrees. And and so what I'm going to do is I'm actually going to convert these data, the projection of these data from WGS84 to a UTM guy. And again, luckily, you guys have made these beautiful, beautiful videos, including one called Project. Amy Durham made this one, and it talks about the process of, you know, reprojecting a data file into a new. So before I run kernel density, I'm actually going to take the step, and it looks like I misspelled kernel there, to project the data from one coordinate system to another. And I like to work in meters personally. You can work in feet or other things. I like to work in meters, and I like to work in universal transverse Mercator projection system. Hopefully this is ringing some bells for you guys. But I need to know what is the UTM zone for Chicago, right? That's a question. What's the UTM zone for Chicago? And so I'm actually just gonna I'm gonna type it in here. What is the UTM zone for Chicago? And let's see. So there's different ones. So what you can click on these guys, geographic coordinates or so on. This Mango map is an interesting one. What UTM zone am I in? So I can, click on this guy. I can find Chicago if it helps if I know where Chicago is. Here's Chicago. I click on this guy, and it tells me, oh, UTM zone 16. All right, so UTM zone. So Chicago's in UTM zone 16. What am I doing right now? I'm going to project these crime data values, which are in geographic coordinates, which are in decimal degrees, a unit that's hard for me to think about when I'm thinking about distances. And I'm going to project it into a different coordinate system. The output coordinate system I'm going to use is, I'm going to select it. I'm going to go to projected coordinate systems, UTM. I'm going to choose WGS84. It's like a more recent one in the Northern Hemisphere. And I'm going to go down to zone 16 north because I just figured out Chicago's in zone 16 north. I'm going to say OK, and then I'm going to just run this guy. And so it's reprojecting these different guys. Hopefully it's going to do some good work. And at the end of that, it's going to create a new guy, right? A new guy. And if I right click on this one and go to the properties of this guy, and I go to the source, and I scroll down to the spatial reference. Now, now it's saying I'm in WGS84 UTM zone 16, and the linear units are in meters. Now I'm happy. Okay, and I'm going to show you in a second why I'm happy here. So let me turn off this original guy, and I'm going to change this name here to UTM, if I can. And I'm actually going to remove this original one. Okay, so now what I want to do is I want to do the kernel density on this one. And we should see some different options in here once I bring this guy in. So if I click on crimes UTM, oh, the values here are now telling me like the output cell size. This is now in units of meters, right? So the output cell size is going to be, each cell of the raster is going to be 1,502 meters by 1,502 meters. I can change. I'll just make this 1,000. So it'll be like a kilometer by kilometer. The search radius is that distance it's going to look to try to count how many points are within that certain range. And I'm going to make this 500 meters, for example. The area units are square kilometers. So again, the point of doing that was to say that the units are instead of decimal degrees, which are hard to understand, and everything's in meters. We're going to go planar, and we're just going to run this guy. And there's a lot of points here, so it might take a little bit of time. Looks like it didn't take that much time. And let's see what happened. So we've got this sort of, some interesting patterns are now starting to come out that we see. Oh, right around here, this is very dark color, and then and there's those patterns can jump out at you a little bit more clear than what we're just seeing from this guy. Now it's pretty blocky, right? It's pretty blocky, and so you can change these parameters. So I'm gonna change this guy. I'm going to make the output cell size. Let's make the 500 by 500. You'll see what that does to it. And the search radius, I'm going to make, I'll make that 1,000 meters. So I'm basically, by changing the search radius, I'm going to say you can look farther away to see if there's any surrounding points. And by decreasing the cell size, instead of these guys being, blocks of 1,000 or, 1 kilometer by 1 kilometer, now they're going to be, 5. Let me make it 250. That'll show you a more impressive difference, I hope, in between these guys. And so it's thinking, it's doing its thing. Hopefully I'm not going to break the computer, and it's calculating away. Oh, right. So now we're starting to see, a little bit more detail here. And again, it's because I decreased that output cell size, and I left the name, so it overwrote. So I lost the original one. But hopefully you guys see these types of patterns jumping out. And to me, if I'm a crime fighter in Chicago, it's more helpful for me to think about how to deal with and put resources and things out if I look at a map like this than if I look at a map like this. Like if I look at a map like this, I'm just sort of overwhelmed, right? And the spatial patterns are not coming out to me too nicely. Whereas with this one, I can start to see some things that are a bit more meaningful. And this is just the default color scheme. We could certainly change the symbology to choose a new scheme. And this includes some transparencies and things associated with it. I'll just choose something like this, just to sort of, right? So we can see these types of patterns. And if you remember, we had this weird, down in Missouri or whatever, we had these additional points. And so that's why it's making it so massive. You also have an option of inputting a barrier feature, which, for example, could be the outline of the city. And if you included that, it would cut this output to only be, values within the city limits, or whatever it was that you were interested in having. Okay, so I'm gonna stop. I'm gonna stop recording, and I'll post this for you guys if I can figure out how to stop recording.